There it goes. Okay, let's talk about combining like terms. Well, before we start combining the like terms, let's talk about what a term is. So a term could be as simple as just a number, all right? That could be considered a term in algebra. It could be as simple as a variable, like a. Oops. There we go. It could be as simple as a variable, all right? It could be a combination. It could be like 5x. That would be a term. It could be something like this, 4y squared. That would be a term. All these are terms, okay? Are there any, Ben, are you up here? Drew, up here? Are there any like terms here? It says like terms. Is this the same as any of these? Well, that's a number, and that's got a number. Are they the same? No, they're not, because that has an x with it, and that doesn't have an x with it. No, there's no like terms here. But what if you had something like this? What if I had 2x and 7x? Are they like terms? Yes. So we can add them together. It's like apples. Okay, this is what I usually use because we have a for a variable. You can only add apples to apples, right? You can't add apples to bananas or apples to oranges. Now people have told me, oh yes you can. If you got 3 apples and 2 bananas, that's 5 pieces of fruit, okay? But that's not 5 of one thing though, is it? All right, so you can only add the apples to the apples and the oranges to the oranges, or bananas to bananas, whatever fruit you like, all right? That's the only thing you can add. So the 2x and the 7x, they are like terms. But then some students say, well, Mr. Hamrick, that's got a 2 and that's got a 7. They're different. But this just tells you how many of those things that you have. This says that you have 2 x's, and this says that you have 7 x's, all right? The term is still the same. So as long as the variable is exactly the same, you can add them, you can subtract them, all right? So when we combine like terms, that's what we're really doing. We're putting them together, and we're either adding them or subtracting them. They don't have to be like terms to multiply or divide. Everybody hear that? So you only need like terms when you're adding or subtracting. So I can add those together. So what is 2x plus 7x? 9x, because I got 9 of them. I got 2 x's, I got 7 x's. How many x's do I have altogether? I got 9 x's altogether. Okay? Let's do another one. Let's go like 3a squared plus 5y minus 4a squared plus 2y. Just made that up, okay? Now, we have more than just one term, don't we? One like term. We do have an a squared. Anywhere else in here do we have an a squared? Yep, we got exactly right. So I can combine those together. So this is what I'm going to do right off the bat. Now, you could just do this in your head. That's fine. But when I first start teaching this, and this is not the first time you've seen this. Am I correct? Yeah, you should have seen this before. But I put them together. I like to put them together. So those two go together because they both have an a squared. Even though we got 3 here and 4 here, all right, it's the variables and the exponents have to be exactly the same. They are exactly the same. And now, do I have any other like terms here? Yeah, I got the 5y and the 2y. So that's a plus 5y. How do I know it's a plus 5y? Well, because you look in front of it. Exactly right. You look in front of it, and that has a plus sign, so that means that's a plus 5y. What's this going to be? That's going to be a plus 2y because of that plus sign right there. Now we can see them. Now we can see the like terms. So we can add those together, and we can add those together. All right? So what's 3a squared minus 4a squared? Right. You could put negative 1a squared, or you could just put negative a squared. You don't really need the 1 there. If you put it there, it's fine. But it looks a little bit better if you just put negative a squared. Why? Because 3 minus 4. It's all the math you're doing. You're just going 3 minus 4, which is negative 1. But then what's the term associated with it? A squared. Same thing here. I got a plus 5y plus 2y, and that gives me what? Plus 7y. And that's how we would add like terms. Can you add those two things together? No, because they're not like terms. They're not the same. This is a squared. That's a y. They're completely different. All right? What if I had, I'll just do the a squared again. What if I had 2a squared plus 7a? Can I add those together? They both have a's, right? But this a is what? Squared. Is this a squared? No, it's not. Are they like terms?
Yeah. No.
They're not. They're not like terms, okay? Because even though they both have a's in it, this is a what? Squared, and this is just an a. So I cannot add them together. I can't say I have 9 of anything, all right? I don't go 9a cubed. I don't go 9a squared. I don't go 9a. There's nothing. There's nothing I can do with that. That's already simplified. That's all I can do. Whatever's going on needs to stop. If there's something on the floor you need to pick it up, then pick it up and then pay attention up here. What's the problem? Do I need to walk over there? Then I'll get your head up. Pay attention. You're in my class. You pay attention to my room, okay? You're not going to put your head down. Ain't happening in here. Here we go. Let's do a couple examples from the worksheet. Okay? So I'm going to pick a couple problems that are right on the worksheet. You're eventually going to have to do them yourself. And let me find, man, they start off super easy. All right, let's do this one. Jump down to the bottom of the page. So we'll call this example 1. It's not number 1 on the worksheet, but you'll see it eventually. They put R. I don't like writing R. Let's go X. I like writing X. I don't know why. It's just easier. Plus 5 plus 3x minus 5. Now on the worksheet, if it has an R in there, you put the R in there. I'm just being lazy. I just like the X. All right, let's take a look. Do we have some like terms? And you might be able to just do this in your head. Okay, a lot of these problems, especially that first page right there, most of these problems on the first page, you probably just do in your head and write down the answer, okay? So we don't really, you know how I put them together on this one right here? Okay, I just did that just to kind of show you for the very first time how to do it. But really, you should just be able to look at it and say 3a squared minus 4a squared is negative a squared, all right? Now, there's some that are going to be a lot longer than this, and so you want to group them together, but these are pretty simple. So what are my like terms? 12x and what else? 3x. What is that? 15x, right? All right, and then the 5 minus 5, 0. Do I need to put plus 0 there? Do I need to put anything after that? Just circle it and you're good to go. It wouldn't be wrong, but you don't need it. Don't do it, okay? So I would not mark it wrong. If you put, plus 0, I would not mark it wrong, but it's just stuff you don't need, all right? So just keep it 15x. It just looks a lot nicer that way. All right. Well, they got to get harder than this, right? Maybe I should find a harder worksheet with combining like terms. Should I do that? No? All right, good. That's what I want to hear. All right, let's do another example. This combines something that we learned earlier in our worksheets. Remember, well, actually, we didn't. Did we do distributive property? We didn't do that yet, did we?
That way you do like number. You gotta.
Yeah, that thing, kind of like this, right? With the lines over top. Yeah. So yeah, we might learn something new here. Well, hopefully it's not new. Hopefully you did this a ton in Algebra 1. 6 plus 7n. Whoops. This graphics tablet is driving me nuts. Maybe that can be my Christmas present. Get me a nice graphics tablet so I can use it at work. All right, here we go. What do we do? Do I go negative 5n plus 3? No. What do I need to do?
You do 3 times 6.
Yeah. That's it. Yep. Now, when we have parentheses, the first instinct should be to look in the parentheses to see if we can simplify it. Can you simplify 6 plus 7n? Can I add those together and get 13 something? No, because they're not like terms. So I cannot add that. So what's happening is, now I go to multiplication. Distributive property basically is multiplication. It's that 3 being multiplied by everything in the parentheses. And I do this, and other math teachers do it as well. That 3 is being distributed, all right? It's being multiplied by everything inside the parentheses. So it's being multiplied by the 6, and it's also being multiplied by the 7n, all right? this negative 5n, I'm not dealing with that just yet, okay? I got to do that multiply by 3 thing first. So all I'm going to do is drop down that minus 5n. Come on, please work. There we go. Plus 3 times 6, 18. And then, again, this is a positive 3, isn't it? This right here, and that's a 6. So we go 3 times 6, which is 18, and a positive 3 times a positive 7. Now, how do we multiply that? How do we multiply 3 times 7n? Do they have to be like terms in order to multiply them? No, they don't. All right? All you do is just multiply the numbers themselves and then just stick the variable next to it. Okay, 21n. Very good. So it's plus 21n. So that's how we do that. We haven't really talked about that yet. Probably should have, but, you know, now we did. Do we just leave it like that and circle it? No, now we look for what? Like terms, okay? So this is something you would not be able to just do in your head and write down the answer. This is definitely something that you need to show your work for, all right? So let's add them up. So I'm going to add up what? Negative 5n and 21n. So negative 5 plus 21. So what is that? 16, right? 16 what? N. Because they're like terms, all right? Just add the numbers out in front. By the way, I didn't say this. The number that's out in front of the letter, like if I had a 3x, the x is called the what? V. What is it? Starts with a V. A letter. Any letter. Yeah, it's a variable. Okay? So the letter itself is called the variable. This one doesn't get as much credit or publicity, I guess, as the variable does. But it does have a name, and we use it from time to time. It's called the coefficient. Very good. So you did learn that. That's nice. Coefficient. All right. So the number out in front is called the coefficient. So I just went through that because when you add like terms, just add the coefficients and then just put the variable right next to it. Okay? So when I say add the coefficients, that means the number that's out in front. So negative 5 plus 21. What's the rule? Subtract. Take the sign of the larger. 21 minus 5 is 16. The larger number is 21. It's positive, so that's 21, or that's 16. Positive 16. And then we just stick the variable next to it. Plus what? 18. Do I go 16 plus 18? No, why not? Because they're not like terms. That's right. So I can't combine them any more than that. So I circle it, and that's my answer. What do you think? Yeah, easy. That's right. I think I'm going to do one more. Actually, you're going to do it. It's one of the last ones on the worksheet. And you know the ones at the end are usually the harder ones, right? So let's give this one a shot. So what example is this? 4? 3? Is it 3 or 4? Okay. All right, so example 3. So here we go. Write this down, and I'm going to give you a minute. And I want to see if you can get the answer on your own without me telling you how to do it. I'll read it off to you in a second. If you can't read my handwriting, which sometimes is not so great. All right, here we go. So it's negative 3, then a parentheses, 10b, that's a b, not a 6. So 10b plus 10, and then this is plus 5, parentheses, b plus 2. Okay? Yes? 2b? This one? Well, do what we did on the first one. Remember, what was the property called? We do what we did with that 3 right there. But you got to do it twice on this problem. So you're taking a negative 3 and you're distributing it, and you're taking a positive 5 and distributing. Right. So now what do you need? Yeah, I want you to do it. I want you to do it and get an answer. That's what I want you to do. To 1? No. You got to keep the b, b. All right? You can't make it a 1. There's no reason to make it. Why would you make it a 1? Because what? No. No, letters could equal anything. All right? It's a variable. That's why it's called a variable, because it varies. It all depends, right? So, no letters are equal to 1. It's just a b. Just work it as if it's a letter. So you say you already got it? Okay, good. All right, give everybody else a chance. Give you a few more seconds. Give you like 15 seconds. All right, who wants to tell me what they got? Anybody? Yeah, Ben. Ben's going to tell me. Very good. That's what it is. Negative 25b minus 20. So let's do it. So we're going to take that negative 3. Now, you got to be careful on this because it is a negative, right? Sometimes that gets a little tricky. We have to distribute it through this one and through this one right here. So that means multiply. Distributive property means to multiply. So it's negative 3 times 10b. So we just multiply the numbers. Negative 3 times 10 is negative 30, and then you got to still put the b right there. Okay? Now we take that negative 3, we multiply it by positive 10. What's negative 3 times 10? Negative 30, so we put a minus, right? The negative means minus, so we put a minus 30. All right, let's do this one. So now we take that 5, it's a positive 5, we multiply it by this, and we multiply it by that. So we're doing two distributive properties here. So what do we get here? Plus 5b, right, because it's positive, so make sure you put the sign. And then it's plus 10. Very good. That is really not this lesson, all right? That's something that we should know before we get to this lesson. But now we're doing this lesson. This lesson is combining like terms, so that's what we're doing now. Since the first one's got the b in it, does anything else have a b in it? Yeah, right here. So I've got negative 30b plus 5b. So just add the coefficients. Negative 30 plus 5, negative 25, and then just a b. All right, so we're done with that one. Sometimes when we do this, if we got a long string of these, because eventually, well, maybe not in geometry, but in Algebra 1 or Algebra 2, you're going to get these that are really long, like 6, 7 different terms, okay, maybe more. I like to cross them out when I'm done with them. You don't have to, but I like to. So now what do we got? Negative 30 plus 10. And that means they're two different signs. You're adding them up, so subtract them. Take the sign of the bigger number. So if I subtract 30 and 10, what do I get? I get 20, and the 30 is the bigger number, so it's negative 20. And that's the answer right there. You can't do anything else with that. Why not? Why can't I go negative 25 minus 20 and get negative 45? They're not like terms. That's right. This is just a number. Here, I'll give you another fancy math word. When you have a number just sitting there by itself with no variable attached to it, just a regular old number, okay, we call that a constant. Think of what those words mean. Constant means it never does what? Never changes. So negative 20 is always going to be negative 20. What about x? That could change, right? It all depends on what you make x, all right? So it varies. So we call it a what? Variable. Make sense? Constant, never changes. Variable could change depending on what you're doing to it, all right? So that's your answer right there. Pretty simple, isn't it? Yeah. All right. That's it. That's all we're going to do. I'll give you a worksheet, and you can work on that. What did I say? This was 38? Okay, so you got plenty of time to work on this.